Hi guys, welcome to all of you for our lecture. In this lecture, we are going to discuss about the Fourier series problem solving. Hope you may remember in our earlier lectures we have discussed the concept of Fourier series and the associated formulae, that is the rules regarding the Fourier series. Okay, now let us consider the problem, that is f of x is equal to x power 2 in the interval minus pi to plus pi. Let us try how to find the Fourier series of the given function. You may remember the rule for the Fourier series, and hence let me go ahead with the problem solving. So the step 1 is to find a naught. The step 1 is to find a naught. The rule for a naught is 1 divided by pi integral the given limit minus pi to plus pi f of x into dx, which is equal 1 divided by pi integral minus pi to plus pi. In place of f of x, this is x power 2 into dx, which is equal to 1 divided by pi. We already discussed regarding this x power 2 and the types of the functions. This x power 2 f of x is an even function. Why it is even function? Can you recall? Very good, good, nice. F of x is equal x power 2. Now put minus x in place of x. So it is minus x whole power 2, which is x power 2, which become f of x. And hence, since the rule f of minus x is equal to f of x whole square, f of x is equal to x power 2, this is an even function. Okay, so since this is an even function, we can write the interval minus pi to plus pi as 2 into integral 0 to pi into f of x dx. So what is the rule behind that? Let me write the rule. The properties of integration, right? Good. So integral minus a to plus a f of x dx is equal twice into integral 0 to a f of x dx. Why? If f of x is an even function. An even function. So which is equal to 1 by pi into 2. This is 2 divided by pi integral x power 2. What is the integration of x power 2? Good, that's an easy one. X power 3 divided by 3 from 0 to pi. Substitute your upper and lower limits here. So this is 2 divided by pi into, first substitute your upper limit in place of x, that is pi power 3 divided by 3 minus substitute your lower limit, that is 0, and hence it is 0 power 3 divided by 3. 0, that becomes 0, simply leave that as it is, which is equal 2 divided by pi into pi power 3 divided by 3. Let us cancel pi and 1 pi, and we left with 2 pi square divided by 3 as the value of a naught. Now the first task has been completed, that is to find a naught. The next one is to find an. So now step 2 is to find an. What is the rule behind this? An is equal, yes, good, very good, 1 by pi integral minus pi to pi, yes, here it is an. No, this is f of x. See, you are writing the rule for an. So this is f of x into cosine nx dx, which is equal 1 divided by pi integral minus pi to plus pi f of x x power 2 cosine nx, it is same, into dx, which is equal, see, x power 2 is even, am I right? We already proved x power 2 is even. Cosine nx, what is the property of cosine nx? In trigonometry you have studied cosine minus x is equal plus cosine x, because cosine is an even function. So this cosine is also even. So here even into even. So the total, the product of the functions inside the integral is even. Very good. So this is 1 divided by pi. Since this is an even function, you can write 2 into integral 0 to pi into the same x power 2 into cosine nx dx, which is equal to, it is 2 divided by pi. Now we have to integrate this. In order to integrate, see, you cannot simply integrate x cube by 3 and this is a sin nx divided by n. Because it is a product, you have to use the rule, very good, udv. You have to use the rule udv, integral by 4. So this is, let us take it as u and let's consider it as dv. So now your integral converted to 0 to pi u dv. So it is 2 divided by pi. What is the rule for integral u dv? What is the rule? Good. uv, 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 etc. Okay. Close your integral. Okay. Put the limit 0 to pi. Okay. Next, minus, plus, minus. Good. Leave the first one. Okay. Dash 1. Next, double dash 2. What is meant by dashes? Dashes denotes differentiation. Where this 1, 2, 3 and all denotes the number of integrations we have to perform. Now let us find the appropriate one for this and substitute everything here. Start with u and here what is u? First let us differentiate. What is u? U is x power 2. What is u dash? Differentiation of u dash is good, easy, 2x. U double dash 2. U triple dash 0. So no need because that's going to be 0 anyhow, right? Go for v terms. So here it is dv. So dv is equal, what is dv? dv here. This is cosine nx dx. What is v? We have to integrate once. First we have to find v, then only v1, v2, v3 and all, okay? So what is v over here? Integrate once, very good. Cosine, right? Sine. Yes. See, there is a coefficient n, so the coefficient of x should be divided. So this is sine nx divide n. Now tell me for v1, integrate again integrate with respect to x. Minus cosine nx divide n, already there is a n, so it is n power 2. Integrate this again, so it is v2 is equal minus integration of cosine, that is sine nx divide n. Already there is still n power 2, so make it as n power 3. And v3 and all, yes, no need because u3 going to be 0, so no need to find any v3s. Okay. Now let us substitute everything in our rule, which is equal 2 divided by pi into u. The value of u is x power 2. V, the value of v, what is v? Yes, this is sine nx divide n minus u dash, the value of u dash is 2x into v1, the value of v1, this one, v1 is minus cosine nx divide n power 2 plus u double dash, this is 2. So it is 2 v2. v2 is minus sine nx by n power 3 from the interval 0 to pi. Before simplifying this, think first. First we are going to substitute the upper limit minus and then we are going to substitute the lower limit. Substitute your upper limit first. This is pi. So pi power 2 sine n pi. Okay, sine n pi. So what is the value of sine n pi? That's good, 0. So the value of sine n pi is equal to 0. What is the value of sine 0? 0. Okay, so if you substitute pi, this term becomes 0. If you substitute pi, this term becomes 0. So in your upper limit only you left with this term. So minus into minus plus, this is 2 by pi into plus 2. This is n power 2 into this is x, in place of x it is pi, into this is cosine and pi. Yes. Minus, substitute your lower limit. In place of x, 0. 0 into any number, this becomes 0. In place of x, 0. 0 into any number, 0. In place of x, 0. Sin 0 is 0. So if you substitute your lower limit, all the terms become 0. So simply leave that as it is. Which is equal 2 into 2, 4. This is pi. This is n power 2 into this is pi. This is cosine n pi. What is the value of cosine n pi? The value of cosine n pi is minus 1 to the power n. So this is minus 1 to the power n. What will happen now? Pi and pi getting cancelled, and we left with 4 by n power 2 into minus 1 to the power n as the value of bn. Sorry, an. Now we have to find bn. The bn, this is step 3. Okay, bn. See, for bn I am not going to write any rule or something else, because already in our rules and properties we have discussed it. For even function in the interval minus pi to pi, the value of bn is good. Really, you have studied, right? 0. So the value of bn is 0. Why? Since f of x is even in minus pi to pi. So the value of bn is 0. Write the Fourier series now. The rule for Fourier series. So now it is step 4. The rule for Fourier series is f of x write the rule for Fourier series now. So the rule for Fourier series is f of x is equal a naught by 2 plus summation n is equal 1 to infinite an into cosine nx plus summation n is equal to 1 to infinite bn into sine nx. So which is equal, what is the value of a naught? The value of a naught over here is here 2 pi square by 3. So this is always divided by 2, so it is 2 pi square divided by 3 plus summation n is equal to 1 to infinite the value of an. The value of an is 4 by n power 2 into minus 1 to the power n. So this is 4 by n power 2 into minus 1 to the power n into cosine nx plus summation n is equal to 1 to infinite the value of bn. The value of bn is 0. So this is 0 into this is sine nx. So 0 into any number, automatically this term becomes 0, and this is 2 into 2 is getting cancelled, and we left with this is pi power 2 divided by 3 plus this 4 is a constant, take it as out. So this is 4 into summation n is equal to 1 to infinite, this is minus 1 to the power n by n power 2 into cosine and next is the value of f of x in terms of the Fourier series. So this is the Fourier series expansion of x power 2 in the interval minus pi to pi. So in this lecture, we have discussed how to find the Fourier series expansion for f of x is equal to x power 2, especially how to find the value of a naught by using the rule, and an, bn by using the property, the Fourier series rule, and the substitution. Finally, we got our result as in terms of the Fourier series expansion. Hope we will be meeting in the another lecture with some other problems and the solutions. With that, see you and bye bye.